Welcome to Trick Your CNC Out, where we talk about the various ways you can improve upon the stock configuration of your Winfinity Elite. Today, install a rotary. Let's take a look first at the motor. It comes with this motor installed, and I wanted to use the Masso motor so I could use the closed loop functionality without and not have to have a stepper driver separately and just have it a little bit cleaner install. So I went out and purchased a second, or I guess a fourth motor, these NM 1.2s that Winfinity sells. They don't have them listed on their website, but you can contact support and order one that way. That's what I did. Now, I did this before the Breaking Z motor came out, so if you've done that upgrade, you probably have a spare motor laying around, in which case, just use that. This is my one that came off the Z-axis. This is the one that I purchased separately, and swapping that out was no big deal. You can handle that, no problem whatsoever, no explanation needed. Now, let's take a look at the chuck. I originally bought the system. It had a 3-jaw chuck. I was unable to find one with a 4-jaw chuck, and I may not have even done it. I mean, had I at the time, I didn't really know what I was doing at all. I just knew I wanted to do a rotary because I wanted to make some chess pieces. So getting this off of this was difficult. There are 3 bolts that went in, I think that these are bolts threaded in that way, or something threaded in that way with a nut on here. But I think the way that this came, these were, there were bolts that were faced in that way. And it was, I mean, you can turn those bolts, get them loose, no problem. But just breaking this free of this after the bolts were all loosened was difficult. At least on my unit. Maybe yours wouldn't be so bad, but mine was. Now, another thing to consider here, I have the 80 millimeter unit. The 100 millimeter unit is possible, but it takes an additional trick. The 100 millimeter unit won't fit with the standard belt that ships with the system, because the bolts or nuts that hold the chuck on end up banging into the motor. So at least I think that's what happens, but there's definitely not enough clearance. But what you can do is get a slightly larger belt, and then there's some screws here you can loosen up and slide, and that's how you tension the belt. So you'd slide the motor away a little bit from the chuck, and then you'd have the clearance you need, and you could fit the 100 millimeter on there. For me, I don't know if I'm ever going to do that. It doesn't seem like I really need it. There is the clearance on the bottom as well, so I could technically do it, but I just, I haven't had a need to yet. Maybe I'll do it when I realize I actually need to. So, got to replace the motor. If you want to do it the way I did without the external stepper motor driver, I put the 4-jaw chuck on there. You don't have to. You can stick with the 3 if you like that, depending on what you're doing. And you could fit a 100, but you'd also have to replace the belt. So that's something to know there. I've got the machine powered off and the housing off. Absolutely turn the machine off if you're taking off the housing and messing around with these wires. You don't want to damage something inadvertently by leaving the power on. Now, the first thing we'll take a look at is the dip switches. I have mine set to 800 pulses per revolution, which is 1 off and the rest of them on. And that's 800 pulses per revolution is a good setting. I think you're going to have really good results on that with small pieces like what you're going to be able to fit on the tabletop here. If you had a separate machine with a much larger diameter capacity for huge stock, you maybe would need to go something bigger. But with small stuff that would fit up here between the clearance between this, the center axis and the table, 800 is going to be fine. And you're going to need to know whatever that number is, whether it's 800, 400, 1600, whatever you choose, when you go to set the settings up on the Masso. So for now, we're going to work off of the 800 that I'm using just for this example case. Now, from a wiring perspective, I've got 2 bundles in here. One is some 18.2 that I had, this red and black stuff. It's the bigger wires. I'm using that for power. And nothing fancy about that. It's just red and black 18-2, and it's not shielded or anything. The rest of these wires are in one bundle. It is a bundle of 2 twisted pair of 24 gauge and 1 pair of 22. The 22 I'm using for enable and alarm. The red goes to enable, the black goes to alarm. And on the enable, you'll notice there's a 2.2 kilowatt resistor in here. I just cut that red lead a little bit short, soldered on the resistor, put some heat shrink around it, put a ferrule on the end of all of these, and connected those up. So that's a 2.2 kilowatt in line with the red to the enable. Alarm is straight to black. And I did this enable this way because that's the way that Onefinity shipped the stock motors to me, and I just wanted to stick with the same methodology that they used. Now these other 4, the 2 pair of 24 gauge, there is a white wire twisted around each of the green and the blue conductors. So what I have done here is I wired green to S+, I wired green's white to S-, I wired blue to D+, and blue's white to D-. And I'll do the same thing on the other end in the Masso when we take a look at that. I ran all of this wire inside this nylon sheathing. That just keeps it nice. It's protected a little bit. It prevents it from separating, getting tangled on things. It's just a lot easier to run and manage like this. And I also put a piece of heat shrink around the end of the bundle to make all those wires nice and tight right before they separate and go back into the back of the housing. With that, we'll move one step further back and take a look at the disconnect. I wanted to have a quick disconnect so that I could remove my entire rotary assembly. That would allow me to either throw down some more wasteboard so I could have more area to cut bigger stock, or I could use the vertical table that I have underneath the rotary. So either way, the disconnect is real simple. It's just a couple Molex connectors that pull apart. No big deal. They have these boots on them that allow them to kind of hold those wires in a little bit nicer and cleaner. And then I just put some heat shrink around the edge of the boots and the nylon sheathing to clean it up even more. But the important thing here is to make sure the pinout is correct. And you obviously have to make the pinout match on both ends. And I'll show you here an image of what that looks like. So if you want to copy exactly the way that I pinned it out, you'll be able to do that. And I'll go ahead and connect this back up, and we'll take a look at that picture. Now with the power off, I've opened up the Masso door, and let's take a look at the wiring. This is the bundle of the 3 pair, and this is the black wire that is wired up to the alarm. I have it crimped into a ferrule here on pin 23, along with another black conductor. So there's 2 black wires going into that ferrule on pin 23. And the other end of it runs into an 1/8 watt 10K ohm resistor into power. And that's it for the alarm. Now on the red one that came from that bundle, that's for enable. And I just tapped into the same ferrule that is used for this green wire that runs back to the e-stop. So I just cut the ferrule that was on this green wire off, put a new ferrule on both that stock green wire and my new red wire together, and put it right back where it was before I messed with it. And that's how I got e-stop working. Now I also grounded the sheathing that came out of this, or the shielding that came out of this. The shielding is that braided shield, and you can see I've got a little bit of heat shrink here around this black wire that I ran into a ground. And I'm only grounding this one end of this because I don't want to create a grounding loop. So I had to add this little conductor to that shielding, made it look a little bit prettier with this heat shrink. And then I wrapped a piece of heat shrink around the whole thing and tightened it up so that it looks a little bit nicer. Now, down here below, we've got the same green and white and blue and white pairs that we had on the motor. We have, again, green going to S+, green's white going to S-, blue going to D+, and blue's white going to D-. And that's really all I had to do inside the enclosure. Now we'll look at how I wired up power to the controller box with that 18.2. The Winfinity power box has these 5 power plugs, and by default, one of them's left open. It doesn't really matter which motor you plug into which of those ports. So we're just going to plug our own cable into whatever one happens to be open. The thing that's really critical about this when you wire this up, and again, I did it similar to the way I did the other end, except for that it's a 2-pin connector, is that you put 36 volts on the right pin and ground on the right pin. So I'll show you a picture here to get this right, but the red wire, which is 36 volts DC, should go to the bottom pin. The black wire, which is ground, should go to the top pin closest to the clip. Now to set up the Masso, we go to our setup screen, and we're going to come down here to input 23, and I'll just set this to not use for a second, but once you double tap in there, you have to scroll way down, somewhere way down, to A-axis motor alarm, and select that. Now, that 23 matches to the input that we chose up here for that ferrule with the 2 black connectors with the pull-up resistor on one end. So, it's important that that 23 matches whatever pin you chose to wire to here. 23 would work fine. And it's also important to know that you're going to have to disconnect this when you disconnect the rotary and store it away, if you do what I did and have that quick disconnect. Otherwise, you're going to get an A motor alarm every time you power up because that motor's not connected. Now, that's a thing you got to remember. And likewise, you got to remember to select this A motor alarm every time you plug the rotary back in. If you don't, it'll work fine until there's an alarm, which won't be detected, and whatever bad thing happens because the alarm wasn't enabled, that could have been prevented if you had remembered to reconfigure this A-axis motor alarm on the proper input. So that's super important to remember to do. Not important until there's a problem, but then when there's a problem, it's really, really important. So that's the one thing. The next thing is the A-axis. So in my case, remember, I had the dip switches set at 800, and that particular rotary is geared at 6:1. So 6 times 800 is 4,800, and that's what I put in right here. The maximum feed rate, 42,000 degrees per minute. That seems like that works. You could probably get away with something much lower. This is really going to be useful for like rewinding, or if you wanted to kind of use it like a lathe, something along those lines. But I think this is a pretty commonly used number in this maximum feed rate. Acceleration I have set at 180. That's worked fine for me. And minimum and maximum travel I have set at 1,000 for maximum and 1 million for maximum and negative 1 million for minimum. And this is so that it doesn't have to rewind if you set this at plus and minus 360, it's going to do a round once and then have to go back before it can start again. So there isn't really a minimum or maximum on the physical unit. So just faking the funk with the software and telling it that it's a super high and a super low range will prevent it from having to rewind unnecessarily. And then obviously you have to select angular axis here. You may have to select invert in direction if you find that you're milling things that are not symmetrical. Let's say it's like you're milling a figurehead and like a bust, and it's different on the left than it is on the right. If you find that your objects are getting milled backwards, you may have to select invert direction. I haven't actually tested that on mine yet, so I might not have this set correctly here. So just a caution. Once you're done with that, hit save, and your rotary is set. Now you should be able to jog and check that it actually works, and you're all set. Time to get into your cam software and make something that uses a rotary. All right, if you're still with me, I thought I might as well show you a little bit about how I mounted it, and I'll try to I'll share some of the stuff if in case you feel like using it. So this is a model in Fusion 360 of essentially the top portion of my CNC table, and all of these MDF wasteboard pieces are too high, and they're held down by all these M5 cap screws into threaded inserts that are embedded into the plywood top, and that's one layer of plywood on top of a layer of MDF, I think. This is where the rotary mounts. It's using 40-20 aluminum extrusions for all of the sides, the short front and back, as well as the left and right. And then there are these corner pieces which hold all of them together. So there's a corner piece, and there's a corner piece, and I wanted to have a method to make sure that the rotary was perfectly linear with the axis. So I have this other piece of MDF that is wedged in between the two 40-20s, and its profile is cut such that it fits directly in the sides. I'll just show that to you. I'll just hide this, the corner, and now we can see, if we look straight on, that MDF piece fits directly in the groove there of the 40-20, so it doesn't want to go anywhere. It's really tight. And I did a bunch of test cuts to make sure that this raised edge was perfectly fit in the receiving slot, I guess, on both the headstock and the tailstock. So I can slide those the headstock and tailstock either direction along the 40-20, and there are track nuts that that fit inside these channels that bolt the headstock and tailstock down, and then I can just loosen them and slide it left or right or position it wherever I want it. Now you can also see there are some holes here in the 40-20 which I use the CNC to mill out. So and there's more than just a couple holes. I think there's 6 or something like that overall. But I use those to mount the whole assembly to the table, and there are threaded inserts underneath those holes that line it up at the same exact place every time. And because I use the CNC to cut those holes in the table as well as in the aluminum extrusions, everything lines up the way that it's supposed to line. I made the tolerances pretty dang tight so those bolts fit through there very snugly. Now that allows me to know exactly where the machine thinks is center, so when I'm cutting on the rotary, the machine knows exactly where to zero Y. At least I know, because I told the machine to cut these holes, and it's halfway between those holes. That's where my X is. So Y doesn't matter as much as long as you don't let the bit run into the chuck or the jaws or anything like that. You're good. And Z is easy because I believe it's a 35 millimeter, and I'll look it up and put a note on top of the video. But actually, I'll go grab a picture of that right now and just show it on the screen. All right, it was a little bit trickier to find than I thought. This image here shows us that the top here is 102 millimeters above the very bottom. So we just need to figure out how high is the center here. And then we can subtract the center from 102, and that's our Z offset when we zero off the top of this block. So we can see that if we scroll down, the MT265 tailstock is what we're using, and its center height is 65, which makes sense because it's an MT2 65. So we are looking at a 37 millimeter offset when we zero off of this height right here. Now, if you're using a probe, you'd actually set to 37. If you're using an XYZ touch probe, you're adding 37 to whatever the Z thickness is of that thing. So I use the 3D touch probe, so I'm just going to use 37, and I'd be done with it.